Z. Now, this is a very challenging question, although you can work it out just from knowing your ions testing. Right, so we should know that our test for calcium ions, Ca2 plus ions, on the addition of sodium hydroxide, you're going to form a white precipitate of calcium hydroxide, okay? So that should have been enough information to make you think that Y is going to be calcium hydroxide. So it's either C or D at the moment, okay? Because the addition of hydroxide ions in the form of sodium hydroxide would result in a white precipitate forming. Now, it will be the same if you're adding barium hydroxide, because barium hydroxide is obviously very soluble in water because it's low down in group 2. And remember, the solubility increases as you drop down. So barium hydroxide would basically have the same effect as adding sodium hydroxide. I do want to explain in a bit more detail why that is. So what I've done here, I've kind of shown you how calcium hydroxide dissociates to form calcium ions and hydroxide ions. So this is what's happening when you form a solution. But what's really important here is that you realize that this process is effectively reversible, okay? So when you have a saturated solution and you make changes to that solution, that's why you will get a precipitate formed. Because if you think of this in terms of a Le Chatelier's principle question, okay, effectively what you're doing when you add hydroxide ions, okay, in this case it's in the form of barium hydroxide, you're adding more of what's on the right hand side here, so your equilibrium is going to shift to the left hand side, like so. In doing that, you're creating more of the solid. Effectively, this is your precipitate, okay? Because you're creating more of that solid. Now, that's the same if I'm getting these hydroxide ions from sodium hydroxide, as you would in a test for calcium ions, or if I'm getting the hydroxide ions from a very soluble barium hydroxide. What I'm really doing is shifting this process to the left-hand side. We're not talking about reaction here between calcium hydroxide and barium hydroxide. We're talking about the effect of adding the hydroxide ions, shifting this process or this equilibrium to the left, meaning you're forming more of this solid, which is giving you that white precipitate. Now, to help explain why Z is going to be barium carbonate here, and your answer is actually going to be C, okay? Z is barium carbonate because if you think about, if you actually went ahead now and you filtered this solution, okay? Remember, you've still got your very soluble barium hydroxide in there, and then you formed this white precipitate of calcium hydroxide. So that's going to collect in your filter paper. That's your calcium hydroxide collecting there. And it's going to be mainly, I say mainly because there will be some calcium ions passing through, but they don't really want you to be thinking about that. You're mainly going to have your barium hydroxide solution passing through into your collecting vessel. Okay, then what happens is if you bubble carbon dioxide into barium hydroxide, effectively this is just like turning the lime water milky test, okay? I'll quickly write out the equation so that can be explained. So here's the equation. If you add barium hydroxide to carbon dioxide, if you bubble in carbon dioxide gas into this solution, you're going to form barium carbonate and water. And this barium carbonate is insoluble, okay? So this will be your white precipitate forming. So that's why the answer is going to be C. Now, just as a little bit of added information, this is kind of a this is a neutralization reaction. What it's not really showing you in the equation here is that in solution, this carbon dioxide is effectively behaving like an acid, and that's why you're getting a salt plus water. It's basically a base plus an acid making salt plus water. You could think of the equation in terms of an acid-alkali reaction. Okay, hope that has helped. The answer there is C.